If we eliminate the lines, the most entrancing star, I accept, is the star that could be dazzling in our sky. It is this one, Betelgeuse, or Scarab Squeeze. It's a red giant star, and if you placed it where the Sun is, its outer layers would reach Jupiter's orbit. It is enormous, erratic, and destined to explode. However, it's not as clear-cut as it may seem. In the universe, these epic events, like the most feared supernovae, could shake everything we know. Betelgeuse has been studied extensively. It is a red giant star that is several times larger than our Sun. Brian Cox and other space experts believe it could go supernova at any time. People are generally frightened by what will happen, especially since the James Webb Space Telescope is capturing stunning images of it. But when exactly will Betelgeuse go supernova? How immense will the effect be on Earth? Let's analyze this star in the constellation Orion. It shines so brightly that even ancient civilizations observed it. The eminent star Betelgeuse is located on Orion's eastern shoulder and is the second largest star in that formation. Its name originates from its prominent position, the monster shoulder. It is one of the brightest stars in the night sky. Not only is it exceptionally bright, but it also has a strange red hue. This has made studying Betelgeuse quite challenging. For centuries, astronomers have been aware of Betelgeuse. A Greek analyst named Timee observed it long ago. At that time, the primary characteristic people noted about stars was their color. Betelgeuse was described as orange. Today, scientists have been paying much closer attention to it and have a much better understanding of what makes it so unusual. One of Betelgeuse's most intriguing qualities is its variable brightness. It fluctuates significantly over time. In 2019, scientists noticed Betelgeuse behaving peculiarly. Though it didn't stop shining completely, it dimmed dramatically, reaching a magnitude of about 1.6. Scientists immediately began investigating why the 10th brightest star in the sky was acting so strangely. Researchers have since made a startling discovery. Betelgeuse could go supernova at any moment. Brian Cox, a renowned scientist and professor of particle physics at the University of Manchester, made this ominous assertion. His words should not be taken lightly. He is also a well-known science communicator, an author of popular science books, and the Royal Society's Public Engagement Ambassador for Science. According to Cox, Betelgeuse is like a ticking time bomb. It could explode without warning. The James Webb Space Telescope has provided substantial evidence to support this claim. But what exactly are the strange signs Betelgeuse has been exhibiting that have alarmed space scientists? Betelgeuse has been classified as a supernova candidate. However, scientists are still unsure when it will explode. One reason for this classification is its massive size. Betelgeuse is several times more massive than the Sun. A star must reach a certain mass threshold to be considered a potential supernova. Things become even more intriguing when we examine the tools scientists have used to study Betelgeuse, such as the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, LIGO. Betelgeuse was discovered long ago, but in recent years, it has exhibited unusual behavior. Scientists detected strange light waves coming from the star, which is highly abnormal. However, that wasn't the only oddity they observed. Betelgeuse's brightness changes periodically, and some scientists believe that it has dark spots similar to those on our Sun. In recent years, these changes have accelerated. The star now fluctuates from bright to dim twice as fast as it used to, a puzzling sign that something is happening inside Betelgeuse. In February 2021, scientists observed that Betelgeuse's dimming cycle had reached a magnitude of 1.61. This occurred shortly after the Great Dimming event of 2019, when Betelgeuse dramatically darkened. Many feared that Betelgeuse was about to explode. The dimming magnitude between 2019 and 2020 was 1.2, the largest recorded since 2011. Experts were certain that Betelgeuse would go supernova within the next 100,000 years. The Great Dimming was a significant event, causing scientists to reconsider their theories. However, what happened next was even more surprising. Betelgeuse became brighter than ever before. Astrophysicist Andrea Dupree, from the Harvard-Smithsonian Center for Astrophysics, reported that the star is now 150% brighter than normal, making it the seventh brightest star in the sky. This increase in brightness has led to new theories about the cause of the Great Dimming. Some believe it was caused by a massive ejection of material from the star's surface. Betelgeuse is classified as a red supergiant, a dying phase in a massive star's life cycle. Its red hue is due to its surface temperature of approximately 3,500 Kelvin, significantly lower than the Sun's 5,500 Kelvin. Because Betelgeuse is cooler, it emits less energy per unit of surface area, despite being enormous and nearing its explosive end. So, does this mean Betelgeuse is about to go supernova? Brian Cox suggests that since it is a red supergiant, it is already nearing the end of its life. Dying stars typically dim over time, which aligns with Betelgeuse's recent behavior. However, the star's fluctuations have left scientists puzzled. Numerous telescopes are now focused on Betelgeuse, trying to understand its unpredictable activity. The James Webb Space Telescope has provided invaluable data. Since its launch in 2021, it has helped scientists uncover new insights about Betelgeuse. Recent images suggest that the Great Dimming was caused by a massive surface ejection, about 400 billion times more than a typical solar ejection from the Sun. The James Webb Space Telescope can observe light waves and frequencies that are invisible to the human eye. This has excited researchers, who are eager to see what new discoveries lie ahead. Scientists have observed dust clouds forming on Betelgeuse's surface, resembling cosmic debris. While it is inevitable that Betelgeuse will eventually go supernova, the exact timing remains uncertain. Some researchers predict it could happen within 100,000 years, while others suggest it might occur within a decade. The recent fluctuations in its brightness make it difficult to determine how soon it will explode. If Betelgeuse does go supernova, it will be the first visible supernova observed by humans since Johannes Kepler's in 1604. Scientists are eager to study such an event up close, but they are also cautious, as they still don't fully understand Betelgeuse's erratic behavior. While it is certain that Betelgeuse will explode, the mystery remains: when will it happen? The cosmic aftermath: what happens when Betelgeuse explodes? If Betelgeuse does go supernova in our lifetime, it will be a once-in-a-lifetime cosmic spectacle. The explosion would be so bright that it could be visible even during the daytime for weeks or months. Some scientists estimate that, at its peak, Betelgeuse's supernova could shine as brightly as a full moon. But what impact would this explosion have on Earth? Fortunately, Betelgeuse is about 640 light-years away, meaning it's far enough that its supernova won't pose any direct danger to our planet. Unlike closer supernova candidates, Betelgeuse's explosion would not produce harmful radiation levels that could affect life on Earth. However, it would be an extraordinary event for astronomers to study. When a star like Betelgeuse goes supernova, it releases an immense amount of energy, generating shockwaves that expand into space. This process enriches the surrounding interstellar medium with heavy elements such as iron, gold, and uranium, contributing to the cosmic cycle of star formation. Essentially, Betelgeuse's death will help create new stars and planetary systems in the future. What will Betelgeuse leave behind? After a massive star explodes, it can leave behind different types of remnants, depending on its mass. 1. Neutron star. If the leftover core is between 1.4 and 3 times the mass of the Sun, it will collapse into a neutron star, an incredibly dense object made almost entirely of neutrons. 2. Black hole. If the core is more than 3 times the mass of the Sun, it will continue collapsing until it becomes a black hole, a region of space where gravity is so strong that not even light can escape. Scientists are still unsure whether Betelgeuse will form a neutron star or a black hole, but given its estimated mass, 10 to 20 times that of the Sun, both outcomes are possible. Preparing for the event: the role of modern telescopes. Telescopes around the world are closely monitoring Betelgeuse. Some of the most advanced observatories, such as the James Webb Space Telescope, JWST, Hubble Space Telescope, and LIGO, are gathering data to understand what stage Betelgeuse is currently in. The James Webb Space Telescope is capable of detecting subtle temperature changes and light fluctuations, which could give scientists early warning signs of an impending supernova. The Hubble Space Telescope has provided valuable ultraviolet data, helping researchers understand how Betelgeuse is shedding its outer layers. LIGO, Laser Interferometer Gravitational Wave Observatory, is on standby to detect gravitational waves, ripples in spacetime, that might be produced when Betelgeuse collapses into a neutron star or black hole. Astronomers are also using supernova simulation models to predict how Betelgeuse's explosion might unfold. These models take into account factors like the star's composition, mass loss rate, and magnetic activity. What happens next? At this point, all we can do is wait and observe. Betelgeuse could explode tomorrow, next year, or in 100,000 years. However, its unusual behavior over the last few years suggests that it is undergoing significant changes. Whether those changes signal an imminent explosion or just another phase in its stellar evolution remains uncertain. When it does finally go supernova, it will be a historic moment in human observation of the cosmos. Scientists will have the opportunity to gather real-time data on a supernova event, something that hasn't happened in centuries. The information gained from Betelgeuse's explosion could reshape our understanding of stellar evolution, supernova mechanics, and even black hole formation. A cosmic reminder. The fate of Betelgeuse reminds us of the incredible life cycle of stars. It also emphasizes how interconnected we are with the universe. Every heavy element on Earth, from the calcium in our bones to the iron in our blood, was forged in the heart of ancient stars that exploded long ago. As we look up at the night sky and admire the red giant in Orion, we may be witnessing a celestial body in its final moments, on a cosmic timescale. One day, whether in our lifetime or far into the future, Betelgeuse will explode, lighting up the sky in a dazzling farewell. And when it does, we will finally witness the end of one of the most famous stars in our galaxy. The universe, without the lines, potentially one of the most enchanting stars, and maybe, the most astonishing in our sky, is Betelgeuse. This massive red star, at any given point in time where the Sun is, would extend to Jupiter's orbit. This incredibly large, unstable star is impacting the universe in staggering ways. Events like the feared starbursts could drastically change all that we see. Betelgeuse, a red giant star with enticing indications of instability, is several times the size of the universe around our Sun. Some astronomers, including Brian Cox, believe it could go supernova at any moment. The concern lies in the effects of this particular event. Since the James Webb Space Telescope discovered disturbing pictures of the star, the question remains, when exactly will Betelgeuse become a supernova, and what effect will that have on Earth? The possibility of Betelgeuse going supernova has intrigued astronomers for centuries, but recent developments in space observation have brought the star into even sharper focus. Constant evaluation and monitoring have revealed numerous peculiarities that make this red giant a prime candidate for an imminent supernova event. Scientists are now deeply concerned, not just because of the star's enormous size, but also due to its increasingly bizarre behavior. The Great Dimming event in 2019, for example, raised alarm. It marked a sudden and drastic dimming of Betelgeuse's light, something never before observed in such a prominent star. Researchers initially struggled to understand the cause of this dimming, and the unexpected nature of this event only deepened the mystery. Some speculated that this was a sign Betelgeuse was on the cusp of becoming a supernova, while others considered alternative explanations. The dimming may have been caused by a massive cloud of gas and dust blocking the star's light or a change in its internal structure that temporarily reduced its luminosity. After this darkening event, the star's sudden rise in brightness in the following months only compounded the mystery. Betelgeuse's dramatic fluctuations in brightness suggest it might be in an unstable phase of its life. It could be undergoing what's known as a pulsation phase, where its outer layers expand and contract in cycles, releasing bursts of energy. While such behavior is typical of red supergiants, Betelgeuse's rapid fluctuations are unlike anything seen in other stars of its size and type. In addition to these unusual light patterns, astronomers have noted the presence of peculiar features on the star's surface. The aforementioned dust clouds surrounding Betelgeuse appear to form complex, chaotic structures in space, almost like leaves. These structures suggest a turbulent environment surrounding the star. The fact that they seem to be in such close proximity to the star's outer layers raises concerns. These clouds may be formed by outflows of gas due to internal instability, or they could be the result of the star shedding its outer envelope in preparation for a violent transformation. This kind of mass ejection could be a precursor to a supernova, though it's unclear whether Betelgeuse is shedding enough material to trigger such an event. Another key factor in the ongoing study of Betelgeuse is its mass. As previously mentioned, Betelgeuse is several times more massive than the Sun, placing it in the category of stars that end their lives in supernovae. Stars of this size typically go through a series of dramatic phases in their final years, undergoing massive internal changes before their cores collapse, triggering a cataclysmic explosion. Given its size and current instability, it's believed that Betelgeuse could explode within the next 100,000 years. However, astronomical events like these can sometimes occur much sooner, or much later, than expected. The precision of this estimate remains a subject of debate within the scientific community. The possibility that Betelgeuse is nearing the end of its life has led to numerous questions about what its eventual supernova might look like. If it does indeed explode, it will be one of the most important astronomical events ever witnessed by humanity. A supernova explosion releases energy equivalent to the Sun's entire lifetime output and can briefly outshine an entire galaxy. If Betelgeuse were to go supernova, it would be visible to the naked eye, even in daylight, and could remain visible from Earth for weeks or even months. Such an event would undoubtedly captivate astronomers and stargazers alike, but it could also have more serious repercussions for our planet. Despite Betelgeuse's extreme distance from Earth, about 640 light-years away, a supernova of this magnitude could still have effects on our planet. While the explosion wouldn't be close enough to cause significant physical damage, the radiation released could pose a threat to Earth's atmosphere. If the explosion releases a large amount of high-energy gamma rays or X-rays, these could potentially damage the ozone layer, leading to a temporary increase in ultraviolet radiation reaching Earth's surface. This could have detrimental effects on life, particularly on plant and animal species that rely on the ozone layer for protection. In addition to potential atmospheric changes, scientists speculate that a supernova of this scale could alter the dynamic balance of our solar system. The shockwave from the explosion could cause disturbances in the interstellar medium, potentially affecting the trajectories of comets and asteroids. While this may sound like science fiction, gravitational and electromagnetic waves generated by a supernova can have far-reaching effects on the surrounding cosmic environment. A nearby supernova could trigger a cascade of events, rippling through the solar system and altering the orbits of celestial objects. There are also theories that Betelgeuse's eventual explosion could provide valuable insights into some of the most fundamental questions in physics. Supernovae are believed to be key laboratories for studying the nature of matter and energy under extreme conditions. The death of a star like Betelgeuse could reveal more about the forces that govern the universe, such as the behavior of matter at incredibly high densities, the role of neutrinos in energy transfer, and the processes leading to black hole formation. As researchers continue to monitor the star, one thing is clear: Betelgeuse remains one of the most fascinating objects of study in astronomy. Its eventual explosion may unlock some of the greatest mysteries of the cosmos. Until that event occurs, astronomers will persist in their observations, hoping to unravel the many unanswered questions surrounding this star's explosive future.